What is the purpose? Chapter 3D. Yes, anyone? Why to study materials? When you place a material in a magnetic field, or you can say when you want to make a solenoid, you will use some material. That is, if you have to make a solenoid or an electromagnet, when you make an electromagnet, the arrangement is same, that you have winding on a material. Question is, should I use wood or soft iron? Soft iron. So that is a good magnetic material. We want to see how many materials or what type of material support the magnetic field. There are some materials, those will oppose it, where the magnetic field will be less than even in air. So there are basically three types of material, broad classification as per our syllabus. One, first type is what? Dia. Diamagnetic materials oppose slightly, small opposition. Para support slightly, and ferro give a strong support for the same. So this whole chapter 3D deals with three types of materials. One is, first one is what? Yes, first one is dia. Second one is para. Third one is ferro. So first point, that you have a magnetic field. First, you have a magnetic field without placing, this is point number one. Take a north pole, south pole. Magnetic field is there. No material is placed. No material placed. Para, magnetic field is there. Free space, air, you can say. No material is placed. Then and only then you will have the content part of the same, that in case you place a material, then what? Now we will place three material. We will place a dia material here, para at this point, and ferro at this point. Let's see what happens to the field. If you place a block of diamagnetic material, then the lines have tendency to move away, not to move through the material. Earlier, if this is the block place, say, there were certain number of lines, 4 lines were passing per unit area, but here the number of lines passing per unit area decrease. So magnetic field will decrease slightly because this dia material has a tendency to oppose. One, if you place a paramagnetic material, this is a paramagnetic material, then you can see small increase in number of lines per unit area, small support. Third, if you place a ferromagnetic material, strong, very strong, large number of thousands of lines, not 4, 5, 6, 7, but thousands of lines will pass through the same, thousands of lines. So three types of materials. One, dia, which will oppose slightly, para, which will support slightly, and the third one is ferro, will support strongly. Just to give you an idea, I will write some examples. Examples for diamagnetic material are copper, gold, silver, water. Example. Point number two, we can say example is copper, gold, water, silver. Copper. Why? Because we need it in a transformer. In a transformer, you have a magnetic material. The wire is made up of what? Copper. But that material has a tendency to slightly opposite. One. We have some examples of para also. Let me see. Para. Yes. Aluminium, chromium, manganese, lithium, magnesium, platinum, tungsten, sodium, potassium, oxygen. That means aluminium, few examples. Aluminium is one of the example and oxygen is another example. Ferromagnetic material, that is soft iron. Third material, because it is applied. Third material is iron, that is ferromagnetic material, iron, cobalt, nickel. I will say iron is sufficient as an example. Iron, cobalt, nickel, etc. Time with you is 2 minutes to write. 2 points, 2 minutes to write. Point number 3. Formula V is equal to nu times H. We write nu into nu R into H. This is permeability of the material. This is permeability of a free space. This is relative permeability. It indicates that the material is, what is the strength from magnetic point of view of the material in comparison to free space. This material dia is, yes, stronger than free space or weaker than free space? Weaker than free space. That is why it is 1 minus nu r is equal to 1 for free space. This will decrease it. In books you may get 10 to the power minus 4, 10 to the power minus 5, nothing to worry about. I will give just an idea whether it is 0.001. Suppose whether it is 3 zeros or 4 zero makes no difference to me. Slightly less than 1 is the correct answer. Nu r is slightly less than 1 is the correct answer. One of the choices, nu r is less than 1. That is not a better answer. Slightly less than 1 is the correct answer. Because less than 1 can be 0.1 also. This value will be 1 minus 0.0 is almost 0.999. It is less than 1, slightly less than 1 better. Getting what I am saying? So, for this one, nu r is equal to 1 minus this and susceptibility nu r is equal to 1 plus, this is known as susceptibility. Nu r is equal to what? 1 plus minus 0.001 means what? Susceptibility is what? Negative for diamagnetic materials. Para. B is equal to nu naught nu r h is equal to nu naught 1 plus. You can refer to the book 10 to the power minus 4 or 10 to the power minus 5 or 10 to the power minus 3. We have analysis. Yes, this is what? Slightly better than free space. Susceptibility. Susceptibility value is what? Yes, nu r is equal to what? 1 plus susceptibility. It is equal to 1 plus, yes, plus 0.0001. Say, that means susceptibility is what? Positive. Very small, value is very small, but it is positive. Third material, ferromagnetic. B is equal to nu naught nu r into H, iron. And it is, yes, this is what makes the difference. 1000 of the order of 1000. Whether it is 999 or 1000 or even Japanese core, nu r is 4000. Very expensive, but very good magnetic material, 4000. So, nu r is what? Of the order of 1000. That means this makes the magnetic field 1000 times. This, in comparison to air, iron is 1000 times better. Now you know why in electromagnet you make use of iron, steel, stampings, because nu r value is very, very high. So, susceptibility status, nu r is equal to 1 plus susceptibility. It is equal to 1 plus 1000. Susceptibility is what? Positive and very large. Time with you is 2 minutes to write. 2 minutes to write. That means diamagnetic materials have slight opposition. Am I right? Diamagnetic materials, so far conclusion is diamagnetic materials have slight opposition. So we perform one experiment. A magnetic field, place a rod material with a suspension. There is a magnetic field, place a rod of diamagnetic material. The rod has tendency to oppose, that means to move away from the magnetic field. Means what? After some time, when you observe, it will turn in such a way like this. It will place itself perpendicular to the field. It has a tendency to move away. One. This is one example. Second example is, if we have a U-tube, fill this U-tube with the diamagnetic liquid. Switch on a magnetic field on one of the limbs. The result is, this liquid has tendency to move away, so it will move on this side downward, on this side upward, because it has a tendency to move away. What about this para? Yes. It has a tendency to remain aligned. If you perform another experiment, that you take it in a liquid form, place it in a U-tube, you have a liquid in U-tube, sorry. Place this in a magnetic field. The liquid has tendency to move in because there is a small attraction for the same. That means after some time, the liquid in this side will move up because there is a small attraction for the same. Third, ferro for the same, generally this is available in solid form. So you won't perform this experiment. So if you perform this experiment, then the result is same. It will also have a tendency to align itself, strong tendency to align itself along direction of a magnetic field. Time with you is 2 minutes to write. 2 minutes to write. Effect of temperature. The value or the behavior of dia does not change or does not depend on temperature. That means value of nu r or susceptibility, B is equal to nu naught nu r into H. Nu r is 1 plus susceptibility times H. This remains almost constant, same, doesn't vary with the temperature. For para, as temperature increases, susceptibility decreases. Susceptibility is inversely proportional to temperature. If you heat a material, why? We will discuss the reasons also. If you heat a magnetic material, that is para and dia, as temperature increases, susceptibility decreases. Here also you can write with the temperature. As temperature increases, susceptibility decreases. to be discussed in detail. Reasons to be discussed in detail in other questions. 1 minute to write. Dependence on temperature.